let's work the constant acceleration worksheet number 4, problem number 6. And this is one of the more complicated problems on this worksheet of problems. And it says here, a dog runs down the driveway with an initial speed of 5 meters per second for 8 seconds. So it's just got a constant velocity of 5 meters per second. It's going to run like that. Then uniformly increases her speed to 10 meters per second in 5 seconds. So in 5 more seconds, we're going to go from 5 meters per second up to 10 meters per second. What was her acceleration during the last 5 seconds? And what is the dog's displacement? And draw velocity versus time graph. Now, actually, it really is helpful to draw the velocity versus time graph first. So let's do that. Given, here's the driveway. Here's the dog running. Little tail. Ears back. It's not too bad. All right. Now, this dog has an initial velocity of 5 meters per second. And run. And then here, the velocity is still 5 meters per second after 8 seconds. Then we're going to start the problem over again, because then the dog increases its speed. It says an initial velocity of 5 meters per second. But run faster and faster until over here, here's the dog running. Now the dog at t equals 5 more seconds. I'm breaking this up into 2 parts. Constant velocity part, increasing velocity part. And here the final velocity is 10 meters per second. So what I like to do is draw a picture of the problem, try to imagine what's going on. Now find. Part A, we want to know what was the acceleration during the last 5 seconds. So that's the acceleration. For part B, what is the dog's displacement? So we want delta x for the dog. And then part C, we want a velocity versus time graph. So now let's solve. These 3 words, given, find, and solve, you're going to write them hundreds of times this year. And I want you to write the whole word out. Now for part A, I want to know what's the acceleration. Well, the acceleration here is 0. How do I know the acceleration here is 0? Velocity's not changing. The dog's running at a constant speed, constant velocity. But over here we go from 5 meters per second to 10 meters per second in 5 seconds. Yes? So we can use the, and what do I want? I want the acceleration. I know the initial velocity, I know the final velocity, and I know time. So what has those 4 things in it? Or I can say, look, I don't know delta x and I'm not trying to find it yet. So what equation doesn't have delta x in it? On your kinematic equation list, it's number 1. B equals V naught plus AT. Now what I'm going to do is solve for A. A equals, we'll subtract V naught from both sides and then divide by time. See how I did 2 algebra steps at once? Now really this is delta V over delta T, which is also the definition for acceleration. Now I'm going to plug in my values. My final velocity, I'm talking about over here at the very end, was 10 meters per second. My initial velocity was right here. It was 5 meters per second. divided by time. Now this is talking about the time interval in which the acceleration was constant from here to here. So that's a time of 5 seconds. So you have 10 minus 5 is 5. 5 divided by 5 is 1. And you get meters per second every second. Or you can call it meters per second squared if you wish. I'm done with part A. Now part B, I need to find delta x. And I got to do it in 2 parts. I got to figure out this delta x, and then I got to figure out this delta x. So delta x, the total delta x, we'll call this delta x1 plus delta x2. This is a very common technique to break the problem up into 2 parts. Because I've got 2 different accelerations here. Here the dog is accelerating at 0, and here the dog is accelerating at 1. So that meters per second every second. So I've got to break the problem up into 2 parts. Now, you could do this. Well, let me just show you. I'm going to do this the long way. I know the initial velocity. I know the final velocity. I know the time. And I want the displacement. And I know the acceleration. So I can use any kinematic equation I want that has delta x in it. So it doesn't matter which one you use. I'll use one that's already solved for delta x. I'll use the second one. Right, that's the second kinematic equation on your list. But what do we want? The final velocity was 5. The initial velocity was 5. Now, do you see that 5 plus 5 divided by 2 is just 5? And then the time is 8 seconds. We did this for 8 seconds. We went from here to here in 8 seconds. Now, you could have said, look, why are you doing this? This is stupid. Okay? The dog was running 5 meters per second for 8 seconds. So it's 5 meters per second times 8 seconds. How far did the dog go from here to here? 40 meters. This is a long driveway. Now we need delta x2. So we got delta x1. Now we need delta x2. Well, what do we know? We know the initial velocity. We know the final velocity. We know the time. We even know the acceleration. But I calculated this acceleration. What if I made a mistake? Why carry that mistake forward? So I'm just going to use what's given. I'm just going to use that equate. But now my final velocity is 10. My initial velocity is 5. And the time it took to go from here to here is 5 additional seconds. So what is delta x2? Well, what's 15 divided by 2 is 7.5. What is 7.5 times 5? Is that 37.5? I believe it is. How did I get that? Well, 5 times 7 is 35. 0.5 times 5 is 2.5. So 2.5 plus 35 is 37.5 meters. Now I just need to add those together. 40 meters plus 37.5 meters equals 77.5 meters. That's how far the dog traveled. Now I need to draw the velocity versus time graph. I need another sheet of paper for that. So let's do part C. Well, we go 1, 2, 3, 4, 5, 6, 7, 8. And now 9, 10, 11, 12, 13. Because 8 seconds plus 5 seconds is 13 seconds. This is time in seconds. Now the velocity of the dog went from 5 up to 10, so I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6, 8, 10. This is velocity in meters per second. Now, till 8 seconds, this dog is running at 5 meters per second constant. Then at 8 seconds, between 8 seconds and 13 seconds, well, at 13 seconds, the dog is running 10 meters per second. So there's your acceleration. That's 1 meter per second every second. And we're done. And notice something here. This area plus this area plus this area. I'll leave it to you, but add up the area of the rectangle plus the rectangle. Well, actually, make a big rectangle out of this. What's 5 times 13? 5 times 13 would be 65. And what's the area of this triangle here? Well, it's 5, and we times 5 divided by 2. So that's 5 times 5 is 25. It's 13.5. So what's 13.5 plus 65? What is that? Oh, 12.5. Yeah, okay. I was noticed. Wait, that's not right. So this is 12.5 plus, and you get 77.5 meters of displacement, which we got using the kinematic equations. So let me try. I don't think I can zoom out any. Get the whole thing here. Yeah, there we go. And that is problem number 6. Any questions? That is all.